Okay.
What's with you guys? Monday, we have to do all the classes. Or at least Q9 Monday.
Sure. Okay. This is going to be review as well. This is the only slide we're going to go through. Essentially, we're just going to kind of open up our book and look at a graph and apply all these things. No, I'm not going to erase that. Do you guys remember phase diagrams at all? It is kind of what it sounds like. The diagram that tells you what?
The phases.
What phase you're in.
Oh yeah, then we have like certain numbers, and it was like a certain number.
Oh, so it's the boxes.
It was a solid.
Right? Yeah, it'll come back to you once I show you. You should also remember the triple point. We talked about triple point last year. It's where you have three phases that exist at the same time. Okay. From my understanding, you can have a triple point even if you have two of those three phases are technically the same phase. What I mean by that is there are some things that have different structures in the solid form. I don't know if you guys remember that from regular chemistry, but at one temperature it could be one type of crystal solid, and at a different temperature it could be a different shape. Okay, so you could actually have a triple point with that, even though it's not the traditional three different phases like solid, liquid, and gas. Okay, and then we'll talk about critical point, critical temperature, critical pressure as we go through the graph. So let's let me put the graph on the board.
Did you like yesterday that technically just any phase change is a triple point?
But that's where it's actually at equilibrium.
Oh.
So those other ones, you have three going on, but it's because you have different equilibrium points, and so kind of, yeah, I see what you're saying, but not completely.
Okay.
All right, let me put an example of this on the board. So it's a graph that relates pressure with temperature. Let's do, I'm on 479 if you want to get there. You don't have to. I'm going to draw it on the board here. We're going to kind of talk about it. Okay. So we'll go like this. We'll say that this is your typical 1 atmospheric pressure right there. Okay, I'm pretty sure that this arrow, the fact that it actually has an arrow there, means that it continues on off the graph, if that makes any sense. Okay? So what I'm trying to say here is this actually stops here. Okay? If you remember, our triple point is where we can have all three phases at the same time. I should maybe identify that this is the solid phase, this is the liquid phase, and this is the gaseous phase. Okay? I'm not sure why they don't go all the way down. On that bottom one. Oh, I know why. Okay, I think I know why. We'll get to that. Okay? This is your what? Okay, and there were a few things I didn't quite get to of those vocab words. Yes? This is what's called the critical at the critical point would be where we have our critical temperature and our critical pressure. So let me kind of explain what critical temperature and critical pressure means. Okay? I don't know if this, I'm just gonna go a little further, it makes a little more sense to do that. Okay, so what happens here is, this is the relationship pressure and temperature have to each other. Notice as I get to a certain temperature, this stops. What does that suggest? Because depending upon whether I'm above this line or below this line would determine whether I'm in the liquid state or the gaseous state if I were to draw, a vertical line here, right? But after I get past this point, I'm all what? No matter what the pressure is. So what the critical point is there becomes a place, there's a specific temperature where it doesn't matter how much pressure you apply to it, you could have an infinite amount of pressure, it would still stay in the gas form. That's what the critical point is. It's the point where if you go any higher in temperature, there is no way you could liquefy it anymore, no matter the pressure. Does that make sense? It's kind of weird to think about. In our heads, at least for me, I like to think, well, couldn't you, if you pressurized it enough, wouldn't you be able to liquefy anything at any point? Like, and you're compressing it, right? Well, it must have to do with, the certain temperature and its force that it applies that doesn't allow it to liquefy. I'm not 100% sure what the reasoning or the why behind it is, but there is a point in every compound where once you get past a certain temperature, you no longer can liquefy it no matter how much pressure you apply. Okay? So then critical temperature just says, what is that temperature at which if you got higher, you couldn't liquefy it anymore? And what would be the minimum pressure you could apply where you could still get it to liquefy? Okay? I think this is supposed to be stopped there, but I'm not 100% sure. If it were my best guess, there is a point where if you have a really, really low atmospheric pressure, you're just going to go straight to the gas phase. You remember how I talked to you guys about when I worked in the lab and I used a vacuum to lower the atmospheric pressure so that I could get things to boil at a much lower temperature? Okay? There must be a point where if you remove so much of that atmospheric pressure, it's just going to be in the gas phase. Okay? Then you can see this, right? As at a low pressure, okay, I can get gas phase at a relatively low temperature. Okay, but if I increase the atmospheric pressure, I have to increase the temperature to get to the gas phase. Keep increasing the atmospheric pressure, continuing to have to increase the temperature. And that should make sense because boiling occurs when what equals what?
Pressure equals atmospheric.
Yeah, the vapor pressure equals the atmospheric pressure. So if I'm increasing the atmospheric pressure, I'm going to have to increase the vapor pressure. What do we know increases the vapor pressure? Temperature. More temperature, more evaporation, more vapor pressure. Okay? Any questions? I think we could pretty much be done, but.
What is someone on the line between liquid and gas?
What?
What is
It's
it?
going through a phase change.
Okay.
Yep. So like if I'm at this pressure and this temperature, okay, we would say either if I'm adding energy at that point, what would it be turning into? And if I'm removing energy at that point, what would it be turning into? A liquid. Okay, so if you're on a line, you're at a melting point or a boiling point. Yes, remember, you can have varying boiling points, right? Remember we talked about normal boiling point versus, you know, you go up in atmosphere, go up in the atmosphere, you have less atmospheric pressure, you're gonna boil at a lower temperature, right? So there is no such thing as one boiling point. There's lots of boiling points. Now we're just used to one boiling point because we, for the most part, stay at the same atmospheric pressure. Alright, so why don't you guys work on your homework, get you guys hopefully most of this homework done, so you can have a free weekend.